Well, good morning, good afternoon, and good evening, everybody. Welcome to this Aero Engine Supplier Quality Community of Practice event, Process Control Methods. What is Reference Manual 13,006? We want to welcome you to this webinar. We've got a power-packed presentation, so we're going to get right into it. This is brought to you by the Subject Matter Interest Group leg of AESQ, our Process Control Methods group. And so I'd like to begin by first introducing myself. I'm Pete Tatey from Pratt & Whitney. I'm a fellow in quality engineering, and I'll be hosting this particular event with my colleague from GKN, Nicholas Gerbadou. And so Nicholas and I will be working together to bring you this. Also on is Andrew Stout, our co-leader for the SMIG group, who spent a lot of time helping us write this reference manual and all the materials within it. So we've got a good cast here to help with the question and answer session. I see a lot of you are still joining on, and that's great. So this is what we're going to be covering as part of what is within RM 13,006 and the importance of it and how it interacts with other specific reference manuals that are provided by the AESQ to support the Aerospace Standard 13,100 spec that goes live 1/1/2023. Okay, that's the supplemental requirements, the AS 9100 and 9145. So we'll be talking about first, what is our process control methods SMIG group all about? Why this webinar, and where can you find help? We'll point you in the right direction for that. A little bit about our community of practice, and then we're going to walk through RM 13,006 and the value that that reference manual brings, especially when used in conjunction with the other reference manuals as mentioned. There's some case studies that we'll talk about that are in the reference manual. Of course, the interaction with the PFMEA, control plan, 8D reference manuals that are out there, some red flags to look out for, and then we'll do some Q&A. Also, one other item that we added at the last minute is a summary of the 9 process control methods that are specifically documented within RM 13,006. So let's go through an overview. And the key points you can see here, I won't read them all off, but this is to just ground us and calibrate us prior to walking through the details of what's in RM 13,006. So as part of protocol of the webinar, we're recording today's webinar, and it will be on the AESQ website later on this week or early next week. It'll be on there along with a PDF of this presentation that you'll be able to download. And then we'll take some questions during today's webinar. You could use the chat feature for that, and we'll be monitoring those questions. And please remain on mute if you could during the presentation, just to prevent any background noise. That'll help as we present the material. Appreciate that. So why are we putting this webinar together? Well, this is the lead off of many webinars our SMIG group plans to offer you. And we'll talk about that later on. There's a whole agenda we have laid out for next year. This is the kickoff. We want to first communicate the overall purpose of the reference manual 13,006, how it is so important for AS 13,100, which of course is the requirements document. I want to state right up front, RM 13006 does not have any requirements. It's strictly guidance on how to go about implementing process control methods. We want to also describe how it interacts with the other manuals. That's very important. To understand that linkage will help for stronger implementation, especially when you get into chapters B and C of AS 13100. Chapter B is all about APQP and PPAP with the goal of driving process control. And chapter C is all on the use of defect prevention tools, some of which we outline here today. We want to promote the available free documents. So there's one document which you have to procure, AS 13100, but none of the reference manuals cost anything other than your time to download them, along with some other handy templates that are available on the supplementary material page on the AESQ website. And you'll see that linkage throughout this presentation. And of course, we want to answer any questions suppliers may have relative to process control methods. So the purpose of the reference manual. Andrew and I have been on this team together since probably 2016. We took 3 years to pull together originally AS 13006, which is now integrated within AS 13100, and the guidance document that we're talking about here today, RM 13006. This document will provide the user all kinds of practical process control methods to be used as part of control plan implementation when we're planning how to assure that we stay out of the error state and control a process properly. That's where it comes in handy. There's 9 specific methods that we'll talk about that are common. And it's not an all-inclusive list, but it's certainly a really good getting started package. The purpose of the reference manual is to raise the overall capability within our engine component supply chain. And again, whether you're a supplier to Pratt & Whitney or GKN or PCC or GE, Rolls-Royce, Safran, it doesn't matter. We all work to the same script now. And so that's important. 13006, the reference manual, supports AS 9145. That is the APQP PPAP standard from the IAQG. And many of us are seeing that flow down to us by customers. This will help in implementing the requirements of that important specification. And of course, AS 13100 supplements that important specification. We developed this particular reference manual by a group of experts, a global group of experts from many different companies and countries, a very diverse group with the expertise required to bring about such a product. And we make it available to you, of course, at no cost. So when we look at let me just make sure I didn't jump a page. There we go. The interface with PFMEA and control plans, this is where it really starts getting into the nitty gritty for process control methods. You can see it over here, this dotted area on the right. What feeds into it is PFMEA, where we go about identifying our risks within a process plan and the control plan used to mitigate those risks. Well, that's where the control methods come in and help out. And so RM 13004 and 13006 really go hand in hand together. They work very well with each other. And so whether we have product key characteristics identified by a design engineering group or process key characteristics identified by a manufacturing engineer, process control methods will help handle those important features as well as other high risks that are not key characteristic related coming from a PFMEA. So it's important to see how these two work together. Can't emphasize that enough. Whoops, there we are. So what is our SMIG group? That's a subject matter interest group. The purpose of this group is to basically assure that we continuously keep the document up to the latest standard. Whenever, if we were to revise 13,100 and if we needed to revise the reference manual to align with it, or if we get good ideas on what to add to the reference manual, we can do that rather quickly. It doesn't take a long time for us to make a change to a guidance document. And so the subject matter interest group is there to kind of be the curator of the document, as well as provide webinars and education to the supply chain, and also drive the community of practice, which is on LinkedIn. I invite all of you to go to that community of practice, and you'll see a link for that in an upcoming slide. So that's what we're all about. We get together every 2 or 3 weeks, and we meet to go over what we're going to do to help the supply chain that we all share. You can see in the bottom right, we've got some future webinar topics. We'll talk about that on a slide that kind of blows that up and makes it a little easier to see later near the end of the presentation. These are the members of our subject matter interest group. Andrew is on today. I'm not sure if anyone else other than Nicholas and I, but we've got Paul from PCC, Rudy from MTU, Karen from Pratt, Steve Hampton from PCC, Doug Douche from Honeywell, Grant Braun also from PCC, Jeffrey Carpentier from Safran, Marnie Ham from GE. She's also the leader of the problem-solving methods SMIG group on 8D. And I worked very closely with Marnie on developing that RM13000 manual. Marnie's on several of these committees, and Shalish Shinde from Rolls-Royce. Now, as far as the community of practice, there's the link. And again, if you just go to LinkedIn, you can pull that up right away. Please join our community of practice. We're growing, and we want to really love to get that membership up to 500. We're close to a couple hundred now. Again, this is where you can post questions, and we are very adamant about answering those questions, that come from our suppliers. And you could utilize that as a venue to ask questions, and also to see what's going on within our SMIG group, what's upcoming webinars maybe coming down the road. So now what I'd like to do is turn it over to Nicholas, who's going to take you through a walk through RM13006. So Nicholas, I turn it over to you.
Thanks, Pete. Hello, everyone. Well, I'm quite new to this team, so I haven't participated in setting up the reference manual, but I have about 20 years experience working as a manufacturing engineer here in Sweden, and I believe that this reference manual is a really good guidance to be able to create a well-capable process. What you see in the table of contents, it's a summary or highlights of the most of some of the sections or chapters in the reference manual. So going through these ones will help you understand what is needed to be able to create this kind of process controlled process. And I think that Pete will go back and talk about those 9 recognized process control methods in the end. Yeah. You can continue, please. So shown here is the 3 levels for the process control, which is in this pyramid. And if we look at the level 3, we have the foundational activities. We need to have training, standardized methods, capable measurements, maintenance, and environment. We need to have control over that. Often that's generic solutions used in a factory or on a site. On the top of that pyramid, we have the product capability. That is more in a detail how you want to produce a specific characteristic on a specific part. What kind of toolings do you choose? What kind of fixtures? What kind of machineries do you have to be able to make a process with very little variation? In between there, we have the process control methods. That's this reference manual. Those are, for me, the rules and the regulations that you add to the process that you have built, that gives you an opportunity to find mistakes or errors made by man or machineries, and will help you to stop the process before you start making defect parts, so you can do changes. So with this, it also says that you need all 3 levels to be able to have a high capability process. And you can't use the process control methods to take care of a bad capability or not having the foundational activities. You need all 3 of them. And one can't work without the other. So please continue. In this reference manual, there is a lot of examples, case studies, depending on what kind of features you want to control, what kind of data you think you can retrieve from the process. And it's a good way to understand what kinds of scenarios you have, and it will give you guidance to what you can do to control the process. And as Pete mentioned before, I think that the upcoming webinars will be more into details, talking about how to work with these kind of examples and case studies. We can continue. In this manual, there is also a training syllabus. This syllabus is in Appendix C, and it's a guidance for you that work on different companies, different facilities, different sites. When you need to train people on your teams, what they need to understand and what knowledge they need to obtain to be able to work through the reference manual. So I believe this is a good guidance for you to see what is needed to be able to work. We can continue. Pete mentioned the different reference manuals and the interactions between them, and this picture shows it as well. So on the left side, you have the reference manual 13004. That's the PFMEA and control plans. That is the input. So when you do the PFMEA, you come up with a number of causes or ideas why the process could fail. Then you need to establish ways of detecting those, avoiding those before they create failure modes in your process. So that's the connection between the 13004 and 13006. To that, we have the 13010, human factors. One big input is for the PFMEA and for the process control methods is to understand when we have human interaction in our processes. What kind of things could happen? What kind of control functions should we try to obtain to be able to help our operators and machinists to avoid mistakes when they're running our processes. And the last one on the right side, the problem-solving methods. We all know that problems will occur, and we will find things during our process. And when we do that, when doing the root cause investigations, when we have found out perhaps a cause that we hadn't thought of earlier, we bring that back to the PFMEA and we try to design new process control methods. And with that said, it's also that when we could have a process control method that isn't as efficient as we thought. That could also be a part of the problem solving. We realized that our process control method wasn't as efficient as we anticipated in the beginning. And I think it's important to understand that we can't see that as a failure in itself. If we have put in a process control method, we made thoughts, we made ideas on how we would control this process. And if that wasn't efficient enough, well, then we have to go back and redo it and see if we can redesign it, come up with other ways of controlling the process. But don't feel that you have failed if you end up with those kind of issues going through your problem-solving methods. So please continue. Appendix A in the reference manual also is a guidance to you as a user because it has a way to assess the process control system that you have set up. You can do it for yourself to see if you believe that you have done it in the proper way, or you can have it as a guidance when you're assessing other teams or other processes in your sites and factories. And some things to look out for is that you have the process flow diagrams, that you have the PFMEA with the key characteristics, that you have the control plan, you've done the gauge capability studies, you have used non-statistical methods such as error-proofing devices for high-risk areas. You have control charts for key characteristics at point of manufacturing and etc. So this is a really good way of helping you to understand what questions should I ask myself and what questions should I ask the teams around me in my company. So thank you.
All right, well, thank you, Nicholas. So now we'll continue. We'll talk about the 9 process control methods and their reaction plans. You can see the red rectangle highlights them all. And as you go into the reference manual, There's a case study around each one of these. And again, we invite you to pull that manual if you haven't already, download it and go through it. It has a detailed case study around each of these. Not to mention what type of control plans, reaction plan, which is the last column on a control plan, what should it look like for each of these types of methods? So let's take a look at that. So the 9 control methods and the reaction plans, the purpose here in the next few slides, we want to provide suppliers, again, some guidance around the selection of process control methods and what should their reaction plan look like. Now, the reaction plan, again, is commonly misunderstood. It's the last column on the control plan, and it's supposed to align directly to the control method. We need to understand what's the signal provided to the user by the control method that may tell the operator they've entered an error state. The control method provides a signal. The reaction plan describes what to do to get out of the error state. So it might be something like, for example, where if I left my key in the ignition of my automobile and I open the door, a buzzer's going to go off, an alarm. And that's going to say to me that I left my key in the ignition and I have a danger of locking my key in the car. So the reaction plan would simply tell me, take the key out of the ignition, put it in my pocket, exit the car, and now lock it. And I avoid the failure mode or defect of locking my keys in the car. It's probably the simplest example I could relate to this. So the assumption of the reaction plan typically is that a non-conforming part is generated and what the operator should do. Now that's important, but it's not the only reason for the reaction plan. It's really more about how to get out of the error state altogether. So again, process control plan, reaction plans have to be in alignment with the control method, and the control method signal needs to be understood. What is it, and what do I do if that signal goes off? So it's the best process control methods avoid the error state altogether. Those are the causes of defects. Now, these next few slides are extracted right out of the reference manual. A little busy, but very informative. I'm certainly not going to read through all of this, but if we were to take a look at, variable control charts, for instance, for each one of these control methods, we have an application, an example or two, and a reaction plan. So the reaction plan, should be based on alignment with the control method. So if we're dealing with a control chart like we see over here, so I'm looking at this control chart. This is a variable control chart. And there are Western Electric rules that provide the signals that a control chart would give to an operator. Could be a point outside the control limit, which suggests that there's an assignable cause that needs to be investigated and mitigated. Could be a trend up or down. It could be a cycle. It could be a sawtooth pattern, any number of these. It could be a shift or a run, something unexpected. And so the reaction plan wants to be able to instruct the operator what to do if you were to run into any of those particular signals. a run chart with non-statistical limits. Well, that might, down here, that might be something where we have a warning line established, not based on statistics, which would be statistically significant, like in a control chart, but more practically significant. Die wear, for example. We may establish some type of upper warning limit. And if we were to see measurements getting near that warning limit, the reaction plan would instruct the operator on exactly what to do. Do they go and pull the manufacturing engineer? Do we discuss whether or not we need to refurbish the die or rework it? So again, those are some, basic examples. A furnace run chart, tracking a thermocouple temperature. A highly capable general tolerance characteristics on a machine part where tool wear is expected and can be tolerated to a certain point, a practical limit. Not a statistical limit, but a practical limit. You can see viscosity of the slurry used in an investment casting process. That might be what we're monitoring. And that warning limit might tell the operator when to add water to the mixture. Let's take a look at a few more. Let's see here. For some reason I'm not able to continue. I'm not sure why. Let's see, why is this not advancing? Here we go. There we go. Sorry about that, folks. Pre-control. Oh, that's another good one. This is a control method that can be used for a number of good reasons. One, as a means to qualify a setup. And so it actually can gauge the quality of the setup of a particular job. It could also be used as a monitoring method during the production run. And it's not based on statistical limits, it's based on the spec. And so basically, we guard band that spec limit by having the inner 50% limits arrived at. So if we had a tolerance of plus or minus 4 thousandths, plus or minus 2 thousandths would be the inner 50% zone. And that would represent the pre-control limits. And that could be used as a means of controlling the process. And so there's a very specific methodology around how we execute pre-control. 5 pieces in a row after the setup that are in the inner 50% zone of the tolerance. Then we sample every 5th part, 20% inspection frequency. And there are rules when you get in the yellow zone or the pre-control beyond a pre-control limit and what to do. And so that's the signal to the operator that you may have a shift or you may have a variability issue. Again, there's a case study all laid out flat in RM13006 that would walk you through on how to execute this particular control method. Life and usage control. This is good for processes that could degrade over time and where we have a useful life known. And so it could be the number of cycles, it could be a count that is set to avoid any nonconformances. And here's a couple of good examples. All these examples are actual real examples that members of the team pulled together from their plant sites. A forging die is running. for a predetermined number of cycles. Before being removed or refurbished, the life of the die change may manage to coincide with batch changes. Cutting tools with known wear characteristics. So the reaction plan for the forging die example, the operator will be provided a signal by a part or the machine cycle counter. And he'll inform the first line supervision that he hit that non-statistical limit. And so, and they can discuss what actions they need now to take, but it's a warning not to proceed further. Attribute control charts can be used to monitor leaks, counts, defectives, at final inspection, or even through in-process inspection. Inspectors can be counting solder joint defects on a printed circuit board. And so again, these types of charts will send signals to the operator when an unusual or non-random pattern is occurring, and it's time to get some help because it's time to really look at what's going on. Visual process or checklist, like say the one on the right here is right out of the reference manual. And this particular extraction shows a pre-flight checklist for an operator before they run a job. What should they look for relative to the setup, the gauging described to be used, specific measurements that may need to be taken to ensure the setup is correct, assuring the right program was loaded in the controller, making sure gauging and parts are free of foreign object debris. So there's a really good example and case study in the reference manual around the use of visual process checks and checklists. And of course, first piece check, that's common. Validating any setup and the quality of the process prior to we get into that production run. And again, this might be a CMM check of the first part in a batch. We might have a reaction plan that says if the first piece check inspection reveals a nonconformance, well, we know there's something errant within that setup. So the inspector shall inform the line supervisor, the ME, or the producing operator. And so, and then the final one is a test piece evaluation, especially when we have special processes like heat treat, carburizing, nitriting. And in order to understand whether or not we have a conforming process, we have to destroy a sacrificial lamb, pull a part out of the lot to be cut up. And that will help us evaluate the case depth or the case hardness. And that'll allow us to know whether or not that process was successful. So test piece evaluation is the ninth control method. Now I'm going to turn it back. And again, I'll turn it back to Nicholas, but I want to emphasize, go through the reference manual and you'll see case studies supporting each one of those items that I went through rather quickly. Hey, Nicholas, all yours.
Thanks again. We have a number of red flags that we want to highlight for you. Those are signals that we are not working accordingly to this reference manual or other reference manuals in this system. So I think there are 6 of them mentioned here. The first 2 are related to the reference manual 1304. And basically it's when you have the process flow diagram and you have the PFMEA and you haven't updated it so it doesn't reflect the current process, which would end up as a major mistake. So once you want to redesign your process, you must update the PFMEA and the process flow diagram as well. And that is because if we don't do that, we will have problems to identify. We will not identify all the steps in the process, and we perhaps will end up with process steps that doesn't get that process control methods applied as needed. So please change. The next two are measurement system analysis from reference manual 13003. If we have identified key characteristics in our processes and we haven't had the gauge capability study performed, or it's not capable enough, we will end up with a process that seems to be out of control. It will be hard to detect if we have things going out of control with the process. The second one is the one that Pete talked about, that we, in our control plans, that the reaction plans doesn't direct us in what to do with the process. It directs us in a way of saying what we should do with the product. So that's a red flag as well. We can take the last one. And this one is related to the reference manual 13006 and the use of the control charts. And the red flag here is if we don't have them in a manner so the operators that are running the process has the ability to surveillance the process and react to the process. If they haven't been trained in the usage of it and understanding what different kind of alarms mean, that would end up with a process continuing without the reaction needed, and eventually might end up with defect parts. So those are the primary red flags that are identified. Thank you.
Thank you, Nicholas. Yeah, take a good look for those red flags. They're warnings. They're warnings. And by addressing them, we can, build a stronger process control system. So now let's summarize and close. We have some future webinars targeted with members of our team. I was just emailed by Steve Hampton from PCC. He's working on the process capability study. What makes a good process capability study? He's pulling that together right now. And I'm really excited about that. And you can see the description over here on the right. So, CPK values are only as good as what goes into the data used to calculate indices like CPK. What else should we be looking for in terms of the measurement system and statistical control? And then process capability study for true position. We get questions about that all the time. How do we handle that? How do we handle it for one-sided unilateral tolerances, where you got MMC, maximum material condition? That'll be coming up in February. The use of non-statistically based process control methods. Paul Gorg is going to lead that. And talking with him, he's really excited about this particular module because there are a lot. Process control is not all about statistics. State-proofing devices are actually the strongest method of control for the highest risk areas. He's going to talk about that. And so that'll be followed by the power of pre-control. Actually, Andrew's going to be leading that. I got to change that slide. Andrew Stout from our Pratt & Whitney Canada, Canada facility in Halifax will lead that discussion. Pre-control's been around a long time, and it was created in the days where you didn't have calculators and computers on the shop floor. Yeah, it still applies very well today. Andrew's going to lead us in that. We have yet to schedule, or I should say, who's going to be involved with this one, but the 1 hour process control assessment. If you had 1 hour to go into a supplier and to carve out a 1 hour period out of a 1 day agenda for a process control assessment, what would you look for? What questions would you ask? Nicholas touched upon some of those questions on a prior slide. And so we're going to dig into that a little bit more. Why is statistical control a prerequisite for process capability? Just getting CPK values isn't good enough without understanding if the process is, how it's behaving. And then dealing with non-normal data, we get questions about that quite a bit. And finally, conducting capability studies for one-sided geometric features. And this is subject to change. We may combine some of these topics and then add some new ones, but that's what our SMIG group will figure out. But that's generally what we're going to be offering next year. That's our webinar schedule. Let's see what else we got. So question and answer time, it is 12 of, so we can certainly answer any questions that you may have now based on what you saw. So why don't we open it up? Let's see. Chat on here. I'm a little lost because I'm a Zoom guy.
I can go through the questions here.
Oh, okay.
We had one
Wonderful.
question about the PowerPoint presentation and the video, which I answered in the chat, but it will be available on the AESQ website within the next couple of days under past events, where all of the other webinars are currently listed. Let's see what other questions we have here.
And just to let folks know, so here's the AESQ website. You can see it.
Go to
And
events.
go to events.
It takes a second.
Yeah.
Yeah, events gives you a drop-down menu that says past events, and you just
There we
click there.
go. Past events. Go to past events and scroll down. You'll see supplier forums. Here was a great APQP PPAP webinar back in September with video clips and the presentation. This one was another one on 13,004. What makes a good 8D? That was back in May. Again, for each of these, you'll see a presentation and a video. So all right here, this, and you can use this. You know, you may use some of this as training within your facility. Feel free to do that. There's some great information in these webinars.
So there's a question here, Pete. It says, how as a supplier must we endorse inside our QMS?
as a supplier, how must we endorse within our QMS? So,
Yeah.
for instance, you may have, if we're talking about how to integrate process control methods within your QMS, ask yourself, do you have a process control procedure? And like, what or standard work that's controlled? So what tells an ME to create a PFMEA? What tells an ME to select measurement systems and conduct gauge studies on key characteristic measurement systems that are used for key characteristics or even tight tolerances? Um, in essence, what do you have relative to a internal procedure or standard work that would drive the activities that we're talking about? I know within my company, we have an internal procedure relative to PPAP, and it gets into the various elements. And then when we get into the elements around MSA, PFMEA, and control plans, that leads to who needs to do what and how do we go about evaluating whether we met the criteria. So it's a very good question that you ask, because AS 13100 will tell you what needs to be done. The reference manuals will guide you, but you'll need to create within your QMS those level 2 and 3 procedures that describe who does what and when. And so I don't know if that answers the question or not.
So we have another question. There's a
Mhm.
couple here. Is it mandatory to follow red flag?
No, there's nothing mandatory about that. Was put together based on our experiences implementing PFMEAs, control plans, and process control methods and measurement systems analysis internally and with our suppliers. Personally, I've done a lot of PFMEA events at suppliers where we've gone out for several days and walked them through and how to do a PFMEA. And there's a lot that we learned in that experience. And so I felt it was important that as a team, we take our individual experiences and package them in these red flags. It's not mandatory. It's more goodness for you based on what the experts from the SMIG team have seen, so you can benefit from it.
So the next question is, do you think a characteristics matrix is a suitable replacement to the process flow diagram?
I'll take a quick shot at that. It's not a replacement by any means because it doesn't describe the sources of variation, where key characteristics. I mean, unless you amend it to do that, but the characteristics matrix does a great job to talk about the influence particular operations have on the features from the requirements or the drawing. But there's a lot of other things required on a flow diagram, like the sources of variation and the key process inputs directly help a PFMEA team to determine what the causes are of failure modes. The key outputs, which are the dimensions on the characteristics matrix, certainly help to determine what the failure modes are going to be, because failure modes are the opposite typically of the requirement. So, but they are there for two separate reasons. I know chapter 7 and 8 in RM 13004 cover that really in detail. I don't know, Andrew or Nicholas, if you have anything else you want to add to that. It's a good question.
So here's the next question. Can you recap on how you filter the PFMEA into the control plan?
How you filter the PFMEA into the control plan. So if we read through RM 13004, the control plan is primarily where we are going to have inspection of features as really it's centered more around the detection column. Error proofing devices that mistake proof against the cause of failure need not go on a control plan. You could, it doesn't hurt, but it's not needed. Control plan is primarily for those types of controls that require the human being to be part of it. And so the control plan is going to reflect the requirements from the PFMEA and along with the detection controls. It's also going to look at the key process inputs for a given process, which are, help to generate the causes of failure. So, but most importantly, on that control plan, that's where we get into the control methods and the reaction plan, which are the last two columns to the right. And that's where things somewhat fall apart. So control method can't just be operator training. That's important. But as Nicholas pointed out in the pyramid diagram, that's part of the foundation of activities that has to be done. And so we're looking specifically how we control the causes or the failure modes from happening. And so that's what's got to be emphasized. So we can put training on, that's important, but is that the control used during the production run? Or is that foundational prior to the production run? What's used during the run to alert someone that they've entered an error state? That's quite different. And that's what the control plan needs to emphasize.
So here's a training question. It says, what training or experience is recommended to an internal auditor who will be auditing the process for compliance against AS 13100?
So, what training?
It looks like Stuart answered that already down below.
Did he?
Page 33, table 5, he says, which in the AS 13100.
Yeah.
That's a nice little table, auditor qualification, initial training.
And AESQ has a training page on their website also for some general overall training for 13100. Plus we have all of these different webinars that we've been running for the past year and a half that are all recorded and available online.
It's in the 13100.
Oh, 33100. I'm sorry.
I did the same thing.
Yeah, I'm losing my nuggets.
Yeah, page 33, table 5,
Okay.
looks like.
Yeah.
So,
Yeah. Yeah, I mean, that will give you, for an auditor, I'll tell you this, what I'm planning to do with our auditors in the next couple of weeks or in early January. And again, this is the motivation I have for us to provide this 1 hour process control assessment. That's what I'll be training them in. The questions to ask, guidance around each question, what to look for in a process walkthrough when you go out and interview the operator and review the workstation. What do you look for to know whether process control is happening? And so that'll be, so take a good look at that particular webinar when we offer it, because that's going to answer a lot of that. But right now, yeah, look at what's in 13,100 and in that table. What was it? Table 5?
table 5.
Table 5, yeah.
Here's one more question. It says, what CMM data software SPC does your company use? I don't know if we can answer that.
CMM, I'll tell you this, we use something called ProLink. And that takes CMM data, but I believe we are currently looking at some other system down the road as we get into model-based design. And there are systems out there that work very well with that type of methodology, but there's ProLink, Infinity QS. That's another excellent package that's out there that deals directly or interfaces beautifully with CMM data. Mitutoyo does as well. Yeah, there's a number of them, but we use ProLink in a number of our sites.
Okay, it looks like we're out of time here, Pete. So if we want to
Okay.
summarize real quick on the next slide and wrap it up.
All right. Yeah. So, thank you all for your participation today. We hope that this webinar was of value to you. It's important for us to provide value. You're so important. You're the suppliers in our chain. You impact all the OEMs that are part of AESQ, the member companies. And we're very, very, it's important to us that we provide you these webinars and help you in your journey in implementing AS 13100. This is just a piece of that. So we look forward to you coming back and for future webinars, not only in our SMIG group, but look at the others that are on the AESQ website. There's a lot more coming from the other groups as well. So thank you all and have a great rest of the day.